Good morning. Thank you for being here, and thank you for the invitation. It is my honor and my pleasure to come and talk to you about my vision of future spoiler. And I have a question. I don't know if I will be able to see in the audience a little bit, yeah. How many of you have been in the position of a future spoiler? Just raise your hands. How many of you do you think you have the potential of being a future spoiler? I want to see everybody raising their hands. Come on. Yeah. When this is the first time I'm actually wearing a future spoiler suit, and I hope to inspire you tonight to think that every single one of you could wear it, and you really deserve it. When I was challenged to talk about future spoiler, I really wanted to make this vision as realistic as possible. I found it, so what's a future spoiler? Okay, I started with what's a future spoiler? And I think a future spoiler is a person who's trying to make a prediction about how centuries to come will unfold for us, for humanity. And I wanted to make it realistic. I didn't want to make it science fiction. In order to do that, and of course because of my professional deformation, I wanted to present my future vision, a kind future through the eyes of space. And I really want to emphasize on the word kind. I really think our world needs more kindness, and it starts from within every single one of us. So first of all, a future spoiler should be a kind person hoping for a kind future. So to make it simple, I wanted to go first back in time for a couple of 100 years and see, just to make the point of how much humanity actually has developed and evolved already, and what were future spoilers 300, 400 years ago. At the same time, to keep it simple, I wanted to focus on three topics: the view of the world, the role of the individual, and the mobility in the world. So this is just to highlight a future spoiler from the past. This is Giordano Bruno, and he was at that time one of the scientists who said that definitely we were not alone in the universe. So let's see what happened to him. It pains me to see that humans to humans can do this. This is definitely unkind. I really don't think it was helpful either. So this was, I'm really happy that I wasn't a future spoiler at that time, definitely. And I'm really sorry for those who were. So that was the perception of the world. The Earth was the center of the universe, and people were living in fear. There was no respect, actually, for the individual. communication and transportation, talking about mobility in the world, were very limited. Perhaps the riches had access to carriages and horses. And of course, when I was younger, I was actually very impressed by the wigs and the glamour of the French court. Until one time I had to wear one of those fancy dresses, and it was totally uncomfortable, only to realize later on that with the wig came a needle, and the needle was specially designed to scratch for the lice. So life was definitely pretty miserable, I would say, physically and intellectually. Most of the time, people were spending not developing their inner self, but more trying to find means to survive from one day to another. So fast forward to where we are today. First of all, we are in an era of empowering the individual. We are in an era where women such as me and others can stand here in front of you on the stage and talk to you about visions of the future. This is really valuable, and I hope you all appreciate this. We've been, not only that, definitely Earth is not the center of the universe. We know that we've been able to go to the moon several times. We've landed on the surface of the moon for 6 times, and there are 12 people who actually walked on the moon. We are in an era where everybody has access to cars, airplanes. We're all connected. We all have access to information. Every single one of you probably carries a cell phone in your pocket. We're in the era of the Internet of Things and of the commercial space, which is what I'm gonna talk more about. So if you look how much humanity, again, has evolved over the past 300 years, and especially over the past 50, 60 years, where the rate of change has increased tremendously, you will believe me that the prediction I'm making is not unreasonable. So here's another view of the universe. We, humans, built the Hubble telescope on low Earth orbit. Not only that, but in 1995, we pointed the Hubble telescope on a very boring, actually the most boring piece of sky on which with your bare eye you can see nothing. And that's 1/24 million of the whole universe. And we gathered images, and that's the image that came out. That's impressive. There's so much out there. So we're definitely not only not the center of the universe, but we're not alone. The density of planets and galaxies and suns is in the billions. And going back to Giordano Bruno, we have a mission named after another famous physicist, Kepler. And this mission is looking for Earth-like planets outside there, especially planets that could be habitable or that could harbor life. And this number has come back as being non-zero. So probabilistically speaking, there's definitely a chance that there's life out there. It's just far from our reach. We humans have built an international space station. You can see here the astronauts building one of the modules on the International Space Station. We have an International Space Station circling Earth on a constant basis. In fact, there's an application, and you can go online, and you will be notified for when the International Space Station is visible from the area where you are. And there's humans on the International Space Station living there for, apologies, for 24/7. The other thing that's on the International Space Station, we're running a lot of experiments in a reduced gravitational environment, or microgravity. And because I'm a physicist, my definition of microgravity is as follows. We think of whatever surrounds us in terms of phase diagrams, in terms of how systems behave as function of temperature and pressure. However, there's a hidden axis in here, and that's the gravity. So you can imagine developing this database of information for other values of reduced gravity. And this is definitely a pulling force for innovation, the same way when we discovered low temperatures. There's investigations in microgravity going on, not only on just studying the changes in the human body, but also in the material science. So for example, particles don't segregate, they float. You can have a more homogeneous mixture. The native state is that of a spherical floating state. You can have changes not only at macroscopic level, but also at microscopic level. Viruses and bacteria, they behave very different, and they also expressed very different kind of genes than they expressed on ground. So my role is, and my interest is actually to create magnetism around the International Space Station and commercialize a lot of these technologies, bring them back on Earth for both public benefit and economic growth. And so to do this, it requires a change of mindset. We don't think and operate in a ground laboratory the same way we operate a laboratory in microgravity. First of all, it is a 3D laboratory. And you can see you have hardware on the floor and on the ceiling. The way to access this is, again, via commercial space, and SpaceX, with the Dragon capability, provides the access to the International Space Station.
T-minus 1 minute, vehicles will start up.
Final go, no-go poll for launch. All stations respond and poll.
Sys1 is go.
CC1 is go. Flight software is go. Nav1 is go.
And MBs go.
3, 2, 1. And liftoff of the Falcon 9 rocket and Dragon. Falcon 9 is clear to go. SpaceX continues America's mission to resupply the International Space Station.
Vehicle supersonic.
Stage separation confirmed.
And that condition confirmed.
All stations, MB mission A, successful Dragon F9 sub. Thank you for the ride, F9.
You are go for the capture sequence.
And capture is confirmed.
Dragon is restoring America's capability to deliver and return significant amounts of cargo to and from the space station.
There goes Dragon away from the arm.
Confirm visual on splashdown.
So this is us, this is human, we've done this. Isn't that impressive? And every single one of you could contribute to this. I can't state that enough. So now that we have this commercial provided capability to access the International Space Station, what we developed was what we call the verticals of microgravity, where for each commercial sector, we looked into the value of microgravity for future product innovation, product development, by building upon existing examples. And I'll go over a few. So here's an example of an exotic optical fiber. all our telecommunication, all our computers are based on silicon. However, the properties of silicon are very limited, and we have reached basically the limitations of these materials and these technologies that they're built upon. So exotic fibers are the future to go. We have entered the area of photonics with whatever that means, and here's an example of an optical fiber pulled in gravity, that's on the right, and next to it, the more clear version is the one that's pulled in microgravity. And we're working right now in taking the hardware on the International Space Station and manufacturing full spools of optical fiber. The other example that I want to give you, and this is really one dear to my heart, and I call it, it has a touch of space in it. How many of you do you think you're walking around with a product made in space in your pockets? Every single one of you, you just don't know it. I mean, cell phones are indirectly a technology developed from there. But here's a perfume made by Shiseido. It's called the Zen perfume. And it has a touch of space in it. We took a rose in space, a mini rose called Midnight Sensation. And you can see how the volatiles emitted by this rose, generated by this rose were collected in microgravity. The spectrum, these needles, the collections happened over 24 hours. The needle were taken back down on ground. Mass spectrometry was done. And the synthetic version of the space rose was created and was used in this perfume. This is the era where we're looking into building solar-powered data centers and supercomputers. And this is the era where technologies developed to operate in a low gravitational environment are miniaturized, and they have cascading serendipitous effects when they're brought back on ground. So one example is the electronic nose that was originally developed to monitor the quality of the indoor air on the International Space Station. And once it came back on ground, one of the amazing applications that I find is it's being used right now, and it's in testing mode, as a sniffer for lung and brain cancer. These are amazing technologies that we will all benefit in the future. And here's where we're going. We're going from having just the International Space Station operational into developing all these suborbital capabilities, suborbital flights that will be available for doing tourism, as well as other free floaters towards factories. And this is in the next 50 years. Beyond this, we're moving towards creating habitats both on the moon and on Mars. And we're also looking at creating stations, orbital stations. If humans do not want to live on Earth, but they want to live in the outside of Earth, outside its bounds, this will become available in the next 200-300 years. And on a personal level, we will all become citizens of this galaxy. And here's where I encourage you again to close your eyes, look inside yourself, find that kind place, unique place that you've been given, and be part of these citizens of the galaxies. Thank you.